Hi guys, welcome back to our YouTube channel. Today's topic is solar energy. You may recognize these as solar panels.
They're capable of generating electricity from the sun, but how exactly do they work?
In essence, solar panels work by converting radiant energy from the sun into electrical energy that can charge a computer. This is done using photovoltaic cells, PN junctions, and other devices that make the energy usable. In this video, we will describe the process that energy takes through a solar system from photon to electron to battery and to finally charging a laptop.
To understand solar energy, you must first know that sunlight is made up of photons, which are particles with specific amounts of energy. The amount of energy that a photon carries is based on its wavelength. If a photon has a short wavelength, it has a large amount of energy, and if it has a longer wavelength, then it has a small amount of energy. The electromagnetic spectrum represents the range of different possible energies a photon can have. Looking at the sun's emission spectrum graph, are you able to tell which wavelength of light makes the most sense for solar panels to collect? If you said visible light, you'd be correct. The sun emits the most visible light, which is between the wavelengths 740 to 380 nanometers.
Even though the sun produces a lot of visible light, only a small fraction makes it to Earth, and even less makes it to the Earth's surface. On average, interactions between photons and particles in the Earth's atmosphere result in the reflection or absorption of 49% of solar energy. The majority of this energy loss comes from clouds either absorbing or reflecting energy back into space. However, the atmosphere and surface of the Earth also absorb and reflect solar energy. All of these factors can vary depending on the time of year, geography, and weather of where you are. But on average, 50% of the sun's power or solar irradiance is still available for capture by the time it has passed through Earth's atmosphere. Because the Earth orbits the sun on an axis that is tilted, different parts of the world will receive different amounts of light at different times of the year. Here's a visualization of that. Can you guess what part of the world receives the most consistent solar power throughout the year? As you can see, the solar irradiance stays very consistent throughout the year at the equator, and it reaches a maximum value of 1,000 watts per meter squared near noon. At the poles, however, the solar irradiance changes drastically throughout the year. Here at the 49th parallel, the amount of solar irradiance is the highest in the summer months and the lowest in the winter months.
Now that we know how much radiant solar energy the Earth receives, how do we actually turn it into electrical energy? Well, we use solar panels, which use photovoltaic cells made of silicon. They take advantage of the photoelectric effect, which states that when electromagnetic radiation, such as light, hits a material, it will emit electrons. When the photons from the sun hit the photovoltaic cells, they energize the electrons in the silicon to a higher state. Silicon is commonly used in PV cells because its bandgap is optimal for producing electric current from visible light, and it is also cheap and accessible. Simply put, the bandgap of an element is just energy states that its electrons are not allowed to occupy. Inside of the photovoltaic cells, there are also PN junctions, which generate permanent electric fields to direct the flow of electrons. They are formed by joining two pieces of silicon with elemental impurities in them. Once electrons have been excited to a higher energy state, they are farther from the nucleus, meaning they have a weaker attraction to the positively charged nucleus, which makes it easier for the electric field to remove the electron from the atom. Once the electrons have left the PV cells, they travel through the MPPT, which monitors the ratio between the voltage and current delivered to the battery, in order to deliver consistent flow and maximum power. If there is excess voltage available from the solar array, then it converts that to additional current to the battery. The batteries output power in the form of DC, but most devices require AC. To account for this, we use a device called an inverter, which rapidly switches the direction of current to convert direct current into alternating current. Now you know that the sun's radial energy is converted into electrical, then chemical, and then back into electrical power in a laptop, using PV cells, PN junctions, an MPPT, battery, an inverter, and finally, into a computer.
The next couple of videos on our YouTube channel will provide a more in-depth explanation about all the topics we learned today. So if you want to learn more about solar panels, make sure to check them out.